Just like CTE, we have another very advanced feature which is called window functions. And window functions are used by data analysts a lot. And the purpose of window function is to partition the output result set into various windows and do operations on top of it. As I said, what window functions do, they partition or window the result set. Now it works on the result set, not on the actual table. So it partitions the result set. Let's say this is the output result set. And what happens is that the output result set is partitioned. The partition is also known as window. Now this partitioning of the output result set is done by a keyword called partition by or partition by clause in the SQL statement. So we mention the partition by clause in the SQL statement to create these partitions or windows out of the result set. Now after the partitioning is done, we can do various operations at individual partition level. Now this partition can be, let's say, state wise, it can be country wise, it can be group wise, etc. So you can think of partition by as group by, but a little advanced because it does multiple operations even after doing the partition. After partitioning is done, we can do operations like sorting or ordering, and that is done by something called order by clause. And this is also mentioned in the select statement. It is not mentioned after the where condition. This is mentioned before the where condition within the select statement itself. And this is how the syntax is. So we have aggregate function. We have to mention an aggregate function, and then over partition by, and I can mention multiple columns followed by order by for ordering. Order by is not mandatory. If we do not want ordering, that is also fine. And partition by can be done using multiple columns also. Now aggregate function is something which is necessary, and this is basically a part of select statement. So the aggregate functions that I was talking about can be any one of these. So it can be average, count, max, minimum, sum, which are mathematical aggregate functions. Then we have rank, row number, dense rank, etc. to, let's say, do a ranking based on certain value. You can do that also. So this is in a nutshell window functions. I'm not going into too much of details of window functions because it can be a little complicated, right? So that's why let's do some hands-on. These are the business statements. The first one is I want to find out the top orders per customer by price and by quantity, meaning which customer had placed the highest orders. And when I say highest order, it can be by price or it can be by quantity also. Then we'll also find the highest number of items sold for each state. And we'll also find state-wise top seller. So which seller has sold the most per state. And then finally, we'll find the top orders by individual sellers. Can you do this using normal SQL statement? Please go ahead and give it a try. Once you are done, then we can come back and look at the window functions, how we can handle these using window functions. Instead of directly jumping into writing SQL statement, let us try to dissect the questions and find out what should be the partition by, order by, and what aggregate function we can use. First of all, let's go ahead and take a look at the aggregate functions again. And these are the aggregate functions. We have average, count, max, min, sum. And here we have rank, row number, dense rank, percent rank, first value, last value, etc. So the first one, average, count, max, these are mathematical functions. And the second one is used to provide rank based on a certain value, based on the partition and based on order. So what will I do is, we'll try to figure out what should be the partition by clause, what should be in the order by clause, and which aggregate function we have to use. So let us go ahead and dissect the first question. So it says find the top orders per customer by price and quantity. You know that from the orders table we can find this because we have price and quantity in the orders table, and we have customer ID also in the orders table. A single customer must have ordered multiple orders. Let's go ahead and take a look at that, whether that is correct or not. Now I'll do a select count star and customer ID and group by customer ID, because this can also only be achieved if we have multiple orders by a single customer. If we do not have multiple orders, there's no point in finding the top orders per customer, right? So that's what we are trying to figure out, whether actually there are multiple orders per customer or not. And it seems like yes, there are customers who have made more than 100 orders also. So the question is legitimate. We can find out top orders per customer by price and by quantity. First of all, you need to have a result set. Now what should be the result set? So what do we want? We want orders per customer, let's say by quantity. Let's take the quantity first. So let's say orders per customer by quantity. So the result set would contain customer ID, order ID and quantity. So these are the three columns that we want from orders table rather, because we want to find out the top orders. So as I am trying to get the top orders, definitely I'll need the order ID. And as it is per customer, definitely I'll need the customer ID. And I want to find the ranking, or I want to find out the top orders based on the quantity and then based on the price. So definitely I should have either quantity or price. So in this case, I am taking quantity, right? This is the result set. We have customer ID, order ID and quantity. Now what should be the partition? Now the moment we can find out what should be the partition, we know what column to mention after the partition by clause. So as we have to find the top orders per customer, so it seems like we need the grouping for individual customers. So the partitions has to be by customer. So you can have customer ID 1, customer ID 2, customer ID 3, so on and so forth. So it means that as we need to do the grouping by customer, so the partition has to be based on the customer on the result set. So you know what column should be there after the partition by clause. It should be partition by customer ID. And then I want to find out the top orders by quantity. So that means the ordering has to be done by a particular column. And in this case, the column should be order quantity. Now we have actually created the diagram for the window function. We know the result set. Result set is just selecting all the rows. There is no where condition as such. There can be where conditions also. Let's say if the business statement had been like find the top orders per customer by price and quantity for country India, for country USA, etc., then there would have been a where clause. But right now, I want to find out the top orders per customer for all the countries and all the orders. So that's why in the result set we'll have select customer ID, order ID and quantity. That's the result set. And then the partitioning has to be done by customer ID, because we want to find out the top orders per customer. So that's what the partition by would be. And we want to order it by quantity. So the ordering column would be quantity. So the partition by clause would contain customer ID and the order by clause would contain quantity. Quantity descending, because we want to find out the top orders. Now the question is, we have found out the partition by and order by clause. Which function should we use? Which aggregate function rather should we use? Should we use sum, average, min, max, etc.? I don't think it makes sense to find out or to use sum, average, min or max, because we want to find out the top orders. So ranking would make more sense. So let us go ahead and try all the ranking functions that we have, like rank, dense rank, row number, etc. These are the ranking functions, because we want to find out the top orders. It has not mentioned the number of top orders. Should it be 3, should it be 4 or 5? We'll consider 3. So we want to find out the top 3 orders per customer. So we know that this would be the result set, and we know that we'll have to use partition by customer ID and order by quantity. And we also know that the aggregate function that we have to use will not be a mathematical one. We'll have to use something like row number, rank, dense rank, etc., because we want to find out the top orders because this is with the moment I say top orders, it becomes a ranking problem to solve. So that's why I'll use the aggregate functions for ranking, which is row number, dense rank, and just rank. There's percent rank also. I don't think that would be needed. So now let us go ahead and select. First, let's select the result set. So we know that we need to get the customer ID, we need to get the order ID, and we need to get the quantity also. And all of this should be from the orders table. So quantity and all of this should be from orders table. So let me just write it. And now I'll have to mention the aggregate function here. But before that, let me write the partition by and order by. So we know that the partition by would be customer ID. We have already substantiated that fact. And then order by would be quantity, and it would be descending. So that's what we want to find out. Now, what should be the function? Let's try rank first. So rank over partition by customer ID, order by quantity, and let's give it an alias, maybe order rank. So let's execute this. It will take some time because it's a very heavy duty analytics query. So as you can see, even though we have only 1,000,000 rows, it is taking some time for us to show the result. Okay, so the result is out. The customer ID is 1. For this customer ID, all these have quantity 10, meaning all these are rank 1. And then we have rank 9. Why you have rank 9? Because that's how rank works. So you start with 1, 2, 3, 4, 5, 6, 7, 8. So 8 orders have the same quantity and all of them have been ranked as 1. The second one with quantity 9 is actually second, but because 1 has been used 8 times, that's why it is giving it as 9. So I don't think it is useful for our use case. It might be useful for some other use cases, but definitely not for our use case because we want to find out the rank as 1, 2, 3, etc. And if you use the rank function, we do not know how many quantities would be there in with order rank 1. So rank will not be useful. Let's try row number or dense rank rather. So seems like dense rank is giving us the expected output. So it is 1 for all the quantity 10, 2 for all the quantity 9, and 3 for all the quantity 8. So we can use dense rank, but before that, let's try row number also. So this time around I'm using row number and we'll see the output, and I think row number is a little different. It will give 1, 2, 3, 4. So as you can see, it is giving 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, 11. So it does not bother about the equality of the quantities. So it just gives the number as it is. So that's how row number works. So I think dense rank is something which would be useful for us. So let us use the dense rank. Now the problem is that we are getting a huge amount of output and we do not need all. We want to find out only the top 3 orders. And here we are finding, the output is giving us a lot more rows. So now how can you solve that? Can you use where clause after the from statement or after the from keyword? So here as you can see, the number of output is very high. We do not need 4, 5, 6, etc. 7, 8, 9, 10. We do not need all these. We need only top 3 or top 2. Can we use order rank? I don't think we can, because what will happen is that again it is on the result set similar to group by and having, and it is giving us error. So will having work? If I do a group by and I have to do the group by with all these columns and then let's say having order rank, it should not work here also because it is working at some other level. So if neither where condition works nor having works, how can we solve it? So better way is to use city. So what will happen? I can execute this entire statement in the city. I'll remove the where clause here and I know that this order rank would be created. Now I can mention select all the columns and the order rank from CT I am naming it as CT itself, so I am not giving any fancy name, where order rank is less than 3. That means we'll get only top 2. So now it should actually work. So far so good, because we did not get any error. So CT is solving this. Now you can see we can get, so we are getting the top 2 orders for customer ID 1, then we have customer ID 2. Right. So it is working for the quantity. Similarly, we'll do the same for price also. The result set would be customer ID, order ID and price. Partition by would be definitely customer ID, and order by would be price this time, not quantity, because we want to find the top order based on price, not by quantity. So that's why after order by we'll have to use price. And I will change this query. So instead of order by quantity descending, I am mentioning order by price descending. Let's remove the CTE first and let's try to execute the query as is without the CTE. So here is the rank. So 1490.87 for order ID, this one is the top order, then 1490.80, 1488.86, etc. Right, so it is giving proper output. So now we obviously need only the top 3 orders. So in that case, we'll have to use the CTE. I'll name the CTE as order rank and I'll select customer ID, order ID. Now instead of quantity, I'll have to select price this time, and dense rank, because we want rank. Partition by would be customer ID and order by would be price rather than quantity, and it has to be descending as order rank from orders. Now I'm selecting order ID, customer ID, and it has to be price, where order rank is less than maybe 4. I want to find out the top 3. Okay, so I will not mention it as order rank. Let me name it as CT itself. Okay, now it should show me the top 3 orders based on price. So as you can see, for customer 1, these are the top 3 orders. For customer 2, these are the top 3 orders. For customer 3, these are the top 3 orders. So we have solved the first business statement using window functions, using partition by, order by, etc. We also used common table expression. So in this business statement needed 2 advanced features. One is the common table expression and the other one is the window functions. And we use the aggregate function dense rank, because rank and row number did not work for us. Let's go to the second one, and the second one says find the highest number of items sold for each state. Now you know what should be the partition by just looking at the question. Pause this video and try to think what would be the partition by clause. I hope you are done. Let's look at the result set. We need the highest number of items sold for each state. Now here's a catch. We do not have any items in order, so we'll need order ID. So there's an order items table separately for other chapters, but for this chapter I have not put order items dataset. Or we'll settle with order items only. So we do not need number of items. Now for each state, orders table does not have any state. Orders table has customer ID and the customers table has state. Means like we'll have to join 2 tables. So in the result set, we'll have state from customers table, order ID from orders table, and quantity from orders table. Order ID and quantity is equivalent to items. That's what I'm saying. Now as it is for each state, the partition has to be based on state. So we know what should be the partition by clause. Now highest number of items, that will be obviously based on quantity. So the order by should be quantity. So in the partition by clause, we'll mention state, and in the order by clause, we'll mention quantity. And the aggregate function that we are going to use would be dense rank again, because it is the top item, highest item, etc. So we'll use the rank and then rank equal to 1, which will give us the highest number of items sold for each state. You can get the order information, and then from there you can go to order items, right? So let's go ahead and do that. First, let us create the result set. So we need the state first. So state would be from customers, and then order ID, and then quantity. So these are the things that we need, and it would be from orders table, and I'll inner join with customers table on orders.customer ID and customer.customer ID. So this is how we write inner join. So instead of inner join, I could have mentioned comma here and removed the on. Instead of on, I could have mentioned where here. So if I mention the where clause and then mention comma here, that is also an inner join. So this is what the result set is. Now I'll have to partition the result set based on the state, and I need the dense rank function, as you already know, and then over I'll mention the partition by as c.state. I'll have to mention that, otherwise the database engine would not know where is state coming from. And order by would be quantity, but quantity is from orders table, so I'll have to mention o.quantity and then descending. So let's see, and this is the state. So the quantity is 1, all of them have similar number. It is working. Now we need the highest order for each state. So we cannot do that in this particular SQL statement. So we'll have to use CTE. Again, I'm naming it as CTE, and then select state order ID, because I do not need c.state or o.order ID, because all these columns are there in the CTE itself. I'll have to alias the rank output, maybe order rank, and then select that order rank from CTE where order rank is less than 4 or maybe 3, because we want the top 2 orders. So this is what it is. I am getting the top orders for Alabama, for top orders for Arizona, etc. We have solved the second business statement also, and we have used CTE, we have used window functions, we also used joins, specifically inner join. As you can see that as you start using advanced analytics functions, you'll have to incorporate all the features, you might have to incorporate rather all the features of SQL, which contains joins, unions, left join, right join, etc. We have 2 more business statements. I want you to do the hands-on on that. I'll not dissect the last 2. Please go ahead and do it by yourself. If you don't, we can discuss it in our live session.